Hello, my name is Brian Day. I'm the Education and Public Outreach Lead for NASA's LCROSS Lunar Impactor mission. Today we're going to do a brief overview of the mission and see just what it's going to accomplish. The good news is we're returning to the moon. The plan is to have people living in a human outpost on the moon in the 2020s. In order to accomplish this, we're going to have a series of both robotic and manned missions. If you look at a map of the moon, you can see that our previous landing spots have all been clustered on the near side of the moon and all more or less near the equator. That's not because this is the most interesting place to be, it's because it's the easiest place to go. In choosing our site for our lunar outpost, we have several considerations. One of these is the general accessibility of the site. How easy is it to get to? Another is landing site safety. You don't want a big boulder field to try and land in. Another is mobility. We're probably not going to find everything that's interesting right there in one place. We have to be able to get into our lunar car and drive around. Another is having this be a Mars analog. Keep in mind that one of our primary reasons for going back to the moon is to develop the technologies and techniques that we are going to need to live on Mars. Another consideration is power. You have to keep in mind that on the moon, most places have 2 weeks of daylight followed by 2 weeks of dark. And that 2 weeks of dark can be a real problem in terms of power. You either have to carry a lot of really big batteries with you, which are really, really heavy, or you carry some sort of a nuclear power generator, which is also really, really heavy. Now, there are certain areas on the moon where you get much closer to constant sunlight, and therefore, from a power standpoint, those would be very favorable. Communications is also another important issue. It's a lot easier to communicate with the Earth from the near side of the moon than a site on the far side. And geologic diversity. We want to make sure that the place we go is actually scientifically interesting. And finally, I've got here highlighted, it says ISRU considerations. That means in situ resource utilization considerations. Well, just what does that mean? That means being able to live off the land, to use resources that are there on the moon already, rather than having to bring everything with you. One of the really important resources that we will need to have when people are living on the moon is water. And there are a couple of options. We can carry the water with us all the way there, but that's pretty heavy. Water's heavy, and it's expensive to transport water from the Earth to the moon. It costs about $100,000 per gallon. Now, it'd be nice if we could actually find water on the moon. But one thing we know from our experiences with the Apollo missions is that the samples that came back from Apollo were really, really dry. Very little water, if any, on the surface of the moon. The moon is in fact drier than many of the meteorites that we get from deep space. Now, that doesn't mean we're completely out of luck. There is oxygen within a lot of the minerals that you find on the moon, and there's hydrogen coming down in the form of the solar wind. So you could manufacture your own water on the moon from the native elements. But that requires a whole lot of energy. Life would be a whole lot easier if we could just find water on the moon. And it just might be there in certain places. A couple of previous robotic missions to the moon gave us hints that at the poles of the moon, there might be water ice. Back in 1994, the Clementine probe was bouncing radar signals off the surface of the moon. And in the vicinity of the lunar pole, when those radar signals bounced off the surface, they reflected in a way, a really peculiar way, that was indicating that they might be bouncing off crystals of water ice. Now, some people, when they look at that data, they say, look at that, there's water ice. But other people look at the same data and they say, we think something else could have caused it. Another really interesting piece of information came from another probe, Lunar Prospector. This was in 1999. And Lunar Prospector had on board a neutron spectrometer, a device that was able to detect the presence of hydrogen. And it found that hydrogen was really concentrated at the poles of the moon. Now, we don't think that's elemental hydrogen. That wouldn't remain on the moon very long and float off into space. So scientists think that it's probably in the form of some compound. One of the most likely compounds is H2O, or water ice. To test this out, at the end of Lunar Prospector's mission, it was deorbited in such a way that it would crash into the south pole of the moon. The plan was to develop a plume of material going up into the lunar sky that we could analyze and see if there were any signs of water ice. But the problem is that Lunar Prospector came in at a very shallow angle, only 6.3 degrees. And Lunar Prospector didn't weigh very much, and it wasn't moving very fast. So the plume it created wasn't very big, and so we really didn't get any conclusive answers. But it was a neat idea. So if we're going to look for water ice on the moon, just where do we look? And the answer is in these craters very near the poles. There are craters near the poles of the moon where the floor of those craters is permanently shadowed. The sun never shines there. As a result, these craters are very, very cold, over 200 degrees below zero. And they've been that way for billions of years. As comets and meteorites strike the surface of the moon will very briefly have a very tenuous, thin atmosphere that pretty quickly will escape off into space. But any of that atmosphere that gets into these cold, dark craters will encounter what we call a cold trap. And any water vapor that might be in that atmosphere would condense, and it might form deposits of water ice. And over time, over billions of years, you might be able to accumulate a fair amount of water ice.